Okay, so today's lesson is the beginning of chapter 8. It's 8.1. We're going to be learning about quadratic expressions and equations. So to start with, we're going to go through a few definitions. So first we have a polynomial. How about that? A polynomial is a monomial or a sum of monomials. So what we remember from our last chapter is that a monomial is a single term, right? We can have a 4, we can have a 4x, but now we're able to add maybe like a 4x plus 3. That's a polynomial, or a 2x squared minus 3x plus 4. That's also a polynomial, so it's a combination of monomials being added or subtracted. So, and we remember also that things that are not monomials, so not monomials, are when you have a variable in the denominator, when you have a variable that's an exponent, or when you have a negative exponent. These things are not monomials. I didn't spell that right, but okay. So as we go down now, there are certain polynomials that have specific names. A binomial, which is the sum of two monomials, is going to be your 2x plus 3 or 4x squared minus 5y. It's going to be when you add or subtract any two monomials together. So bi means two. Then we have what's called a trinomial. So a trinomial is when you add or subtract three terms together. So say we have 3x squared plus 2x plus 4, or 5x to the 5th minus 3x squared minus 7. These are when you have three terms being added or subtracted together. They're called a trinomial. So all of these are polynomials. They all fall under the category of polynomials, but a monomial is one term, a binomial is two terms, and a trinomial is three terms. So once you are able to identify polynomials, anything more than three terms will be just called a polynomial. We have what's called the degree of a monomial, which is where we look at the exponents. So for example, we have this term right here, 2x squared y to the third. So I'm going to add the exponents, the 2 and the 3, which gives me 5. The degree of this monomial is 5. So when I'm looking to find the degree of a polynomial, right, that's going to be the greatest degree of all the terms in the polynomial. I have to look term by term and figure out what the degree is of each term. So here, since y doesn't have an exponent, we know it's a 1. So the degree of this term is 3, the degree of this term is 7, and the degree of this term is 6. So when I want to know the degree of the polynomial, I'm going to choose the largest of all the degrees. So now when we're going to do some example problems, we're going to look at terms, we're going to look at polynomials and decide if they're a polynomial, and if they are a polynomial, identify it as a monomial, a binomial, or a trinomial. So here in example A, we have 15m to the third n to the fourth. That is a monomial. Yes, it's a single term, monomial. So yes, it is a polynomial. In example B, we have this variable here in the denominator, so we know that this is not a polynomial. We have not a polynomial. When we go to the next page at the top, we have example C. We have three terms. None of them have variables in the denominator or negative exponents or variable exponents. So yes, this is a polynomial, and since it's three terms, it is a trinomial. So all we have to do for these is identify whether it's a trinomial, binomial, monomial, and if it's not a polynomial at all because it falls into that category, then we put not a polynomial. In example 2, here we're going to find the degree of each polynomial. So we're going to look term by term to see what the degrees are. So the first term is degree of 1, the second term is 4, the the third term is 2, and the last term is 3. So I'm just looking at the exponents, and then I'm going to choose the largest exponent, which is 4. So the degree of this polynomial is 4. For example B, the first term, the degree is 4. I'm adding together the 2 and the 2. The second term is 3. The third term is 5. So the degree of this polynomial, which is the largest of the degrees, is 5. And the last example, the first term, the degree of the polynomial is 5, and the degree of the second term is 4. So the biggest of the degrees is 5. So once we know the degree, how to find the degree of the polynomial, we then need to be able to rearrange the order of the terms in terms of x. So first, the first way is to arrange the terms in ascending order. And we know for ascending, just like in a plane when it's going to ascend, that means it's taking off, it's going up. So we're going to go up or put our terms in order of least to greatest. And that's going to be dependent on the exponent of the x. Least. So make sure you're writing all of these things down into your note packet. So I'm going to look at these three terms here in example A. I have 8x squared minus 15 plus 5x to the fifth. So I'm going to find my term with the biggest exponent, with the smallest exponent, and that's going to come first because these are going to be in order from least to greatest in terms of x. So my next greatest term is 8x squared, and then my biggest x is 5x to the fifth. So ascending order means I started with no x's and then I moved up to where I had the most amount of x's at the end. So I'm going to do the same thing with example B. I'm going to start with no x's because these are going in ascending order, and then I'm going to put the terms in order as x gets larger. So then we put a squared x squared, and then 3ax to the third. So now if you look at the x's, we have in the first term there are no x's here. Then in the next term we have 1x. Then we have 2 x's, then we have 3 x's. So no x's, then we have x, x squared, x to the third. And those are in ascending order. So the opposite of ascending order is to put the terms in descending order. In descending order, just like in a plane where you're descending, they're going down. And when they go down, that means you're putting them from the greatest number of x's to the least, greatest to the least. So now when I look at my first example, I'm going to find the biggest x exponent, which I see here is 6x to the third, and then I'm going to write them in order as x gets smaller. So we see here that x goes 6x to the third, then x squared, 13x squared, then minus x, then minus 5. 5 has no x's, so it has the least. So the next example, you have two variables. We're still only looking at the x. So I still want to start with the largest x exponent, and then I'm going to put them in order only with the x. So we disregard the r. The r stays in the term, but it has nothing to do with how we order them. And so when we write these ones, we start with the largest amount of x's, which here was x to the sixth. Then we're going down, x to the third, then x, and then here we have no x's at all. So that is putting your polynomial in descending order. It's also called the standard form. So if you need to take a minute to write all those things down, go ahead and pause this, and then we're going to start back on the last section of chapter 8.1. Okay, so the final part of this lesson is combining like terms or adding and subtracting polynomials. So to add like terms, if you remember from back in the beginning of the year, we're going to find our variables that are like, and we're going to add the coefficients. So here in example A, I'm going to add my 4y and my negative 7y to get negative 3y. And I'm going to add my 5 and negative 1, which 5 plus negative 1 is 4. Once I've combined my like terms, then I'm finished. That is my answer. So when we're adding polynomials, we are combining like terms. When we're subtracting polynomials, like example B, we are also adding like terms, but because the polynomials are being subtracted, we have to account for that subtraction in the second polynomial. So I'm going to change my signs. I'm going to distribute the negative basically through there. I'm going to bring down my first polynomial, and then I'm going to combine my like terms. So here I don't have another k squared, so that term is going to stay just as it is. But then here I have 8k minus 2k, so I'm going to combine those together. 8k minus 2k is 6k. And once I finish it, I'm going to exit out so I know I'm done. And then I have 2 minus 3, which is negative 1. So 4k squared plus 6k minus 1. So that is my final answer. I can't combine any other terms. In example C, I have another subtraction. I'm subtracting the second polynomial. So I'm going to go through and I'm going to change my signs here, and I'm going to bring down my first polynomial as it is, and then I'm going to combine my like terms. So I find I have 5a squared minus 7a squared. When I combine those, I get negative 2a squared. Once they're combined, I'm done with them. I'm going to find the next like terms. I have a 6a plus 7a, so that is 13a. And then I have 2 minus 5, which is negative 3. So negative 2a squared plus 13a minus 3, that's my final answer. I'm just combining my like terms, but when they're being subtracted, again, I have to account for that negative in the second polynomial. So in example D, they're just being added. So I'm going to add my like terms. I have 4 plus 3u squared, which is 7u squared. I have, and now I'm done with those, I have negative 2u minus u, which is a negative 3u. Done with those, and then I have negative 3 plus 4, which is plus 1. Once I'm done combining my like terms, and my answer is finished. So there's also problems where you'll have to add or subtract more than one set of polynomials. So here I have 3 polynomials that I'm subtracting. So now I have to account for this negative here and here. So I'm going to go ahead and bring down my first polynomial, and I'm going to change the signs of all my other terms so that I can add them together. So I'm distributing that negative through both sets of parentheses. And now I'm going to find my like terms. So I have 6f squared minus 5f squared minus 2f squared. So 6 minus 5 is 1, and 1 minus 2 is negative f squared. So now I'm finished with those. I'm going to go to my f's. Negative 7f minus 2f minus f. So negative 7 minus 2 is negative 9, minus 1 is negative 10f. And once I'm done with those, I can cancel them out, and then all I have left are my whole numbers. Negative 3, positive 1, and positive 3. So negative 3 and positive 3 becomes 0, and 0 plus 1 is 1. So here we have our answer to example E. And now our final example of adding and subtracting polynomials is an adding. These are all being added, so I'm just going to go ahead and find all of my like terms. So let's start with x. 2x plus 4x plus x is 2 and 4 is 6, and 1 is 7x. Then we have 6y minus 8y minus 3y. 6y minus 8y is negative 2y, minus 3y is negative 5y. So now I've done my x's and my y's, and I have left my z's, negative 3z plus 6z, which is 3z, plus another z, which is 4z. So that is how we add and subtract polynomials. And if you have any questions, we are going to go over them on Monday. Have a great weekend.